Our next presentation is grip change as an information side channel for mobile touch interaction. And our presenter is Matei Negulescu. And this is a note, so it's a bit shorter.
So thank you. So this is work I did along with my supervisor, Joanna McGrenere at University of British Columbia. So this kind of all work came from an observation that users tilt and shift the mobile device in their hand to reach targets around the display. And this is kind of using the one-handed posture. And in fact, at LASCHI, Noor et al. Were able to predict these on-screen touches using grip change detected with a rear capacitive sensor array. So, kind of in our work, we're interested in two research questions. First, can we predict where a user's finger is going to land through this kind of grip change, but only detecting it using internal sensors, so just accelerometer and gyroscopes, which are found in common mobile devices. And so, second, can we use this grip change to predict where they intended to touch down? And this is important because even after they've landed, they may not be where they intended to touch. Regardless of where they touch down, where do they want to touch? And maybe this kind of grip change can provide some kind of measurement of where they intend to touch, and we might be able to adjust their touch points and somehow reduce their error rate. Okay, so I'll just cut to the chase and tell you what we found, and I'll take a step back. In terms of this kind of in-the-air prediction or en route prediction, we found that using this grip change detected using accelerometer and gyroscopes can predict touch endpoints in multiple physical scenarios, so both static and more dynamic scenarios like interacting while on a bus or something like that, or while walking. In terms of once they've already touched down, we can use the preceding grip change to infer intent and adjust the touch points, and this kind of leads to a very kind of easy to get 41% reduction in touch errors across all the different physical conditions. And so now, kind of taking a step back, I'll go through some of the studies that we used to answer these questions. So our first study was kind of focused around in-the-air prediction, and we had a kind of ideal targeting task which had an imposed delay between touches, and this is very useful in segmenting the motion. And this is kind of similar to what Noor et al. Did. And secondly, we also wanted to verify how our grip change predictive models behave in varying physical conditions. So, for instance, walking. Because we're using these internal sensors, we are at risk of noise coming from the environment. So we really wanted to have a second study which was more realistic in two ways. First, we have a much more realistic task. And a second, we have kind of four different physical conditions spanning the different kind of degrees of motion. So both static conditions like interacting while sitting and standing, but also more dynamic ones like interacting while walking and just random noise given by interacting while on the bus. So let's delve into the results of kind of our in-the-air prediction using mobile motion sensors. So here what we're trying to do is create a model from our data that will take the motion sensor data preceding the touch and map that onto 2D touch coordinates. And so we built such a model, and here are the kind of the results in our first study. So on the y-axis is error in millimeters, and on the y-axis it's seconds, so kind of time before touch. And we can see here that the baseline in red is kind of if you have no information and you just guess in the center of the screen, that's the kind of error rate that you get. And so what we can see here is that our predictive model has an error rate that's kind of consistently below random chance, and it's significantly better so, in fact. And in fact, if we look at making a prediction 0.1 seconds before the touch, we have a mean squared error of around 20 millimeters. And this is kind of in line with some of the past results. So now moving on to kind of in the second study, which had the same type of model being created in all these different conditions, we find that we again consistently have like a lower than baseline error rate in all the different conditions. And in fact, if you notice here, actually the baseline is higher, and that's because here the task is much more realistic. There's no imposed delays. There's a higher distribution of targets and everything. So we can see here that even at 0.1 milliseconds while walking, we have a mean squared error of about 24, 23 millimeters. Okay, so now moving on to kind of this grip change for touch adjustments. Remember, what we're trying to do here is figure out if there is a way to use the grip change preceding the touch to infer where they actually intended to touch, and find out how we can use that, and if that's useful for improving touch accuracy. So here we have kind of 3 different types of information. We have kind of the raw touch points, and this is just where they clicked. And second, we know from past work that users have a systematic error pattern in the way they touch. So so we use a kind of just a regression model that maps their touch points and adjusts them to find out kind of patterns among participants. So that we call that the XY model. And last is our model, where we use not only where users touch, but we also use the preceding grip change as detected through motion sensors, and we call this the XY plus grip model, and to figure out where they actually landed. All right, so kind of what we find here, this is a kind of chart on all of our conditions in experiment 2. And you can see here that the green bars there represent our XY plus grip model, and it kind of consistently, it is very consistent and very standard improvement of, over the baseline. It goes from something like 80% to over 90%. And in fact, this is an improvement even over kind of more traditional systematic regression models, the XY model, by it might not seem like a lot, but that's actually an improvement of 41% in terms of error rate. And so this is a small but consistent improvement across all the different conditions. And in fact, we get this actually for free. All we have to do is just record the different the accelerometer and gyroscope values and run them through our model. And so you get this kind of improvement for basically nothing. Okay, so kind of in conclusion, I kind of talked about this idea of using grip change to predict touch points using solely mobile motion sensors, and we found that it kind of it provides reasonable results, and it's a preliminary result that it can be used to augment existing techniques. And secondly, we actually find that by just using the grip change preceding the motion is a valuable information about where users intended to touch, and using that information in a touch model reduces our error rates by 41%. Well, I'm looking for a job. No, just kidding. I just wanted to say that. All right. Questions?
Hello again, Sunjun Kim from KAIS. Was there any tendency of the error tendency along to the location of the touch point, for example, the previous work?
Yeah. So actually, in this previous kind of slide, we see that there is an actual the location plays a big role in the location of the target plays a big role in how people what errors they make, and so our XY model is meant to kind of account for that. It's kind of just adjusting for the systematic errors, and so we can see that the systematic errors, the XY model improves accuracy actually significantly over the raw touch points by around 5%, and then we get an extra boost of 5% on top of that by using the grip change as well. And so yes, there is a location factor, and there's also a grip factor.
Thank you.
No problem.
Hi, Daniel Buschek, University of Munich. I wondered if you would get additional improvement by considering the previous touch location. Have you any comments on that?
Yeah, that's a great point. So certainly, I think that there's a lot of exploration. We didn't use any of the prior knowledge, basically, and of course, there's both prior knowledge and task-centric models that figure out what what's the predicted next target. We didn't actually do this here. These were completely random kind of opportunities. So yes, of course, you can improve vastly by just using some additional information. And we'll be doing that next time. Yeah.
Thank you.
Okay, this is the last talk of the session, but not the least. It's also a note. It's called An Experimental Comparison of Vertical and Horizontal Dynamic People Navigation, and Jens Müller is going to be presenting.
Okay. Hi, and thanks for coming. My name is Jens Müller. I'm from the University of Konstanz, and I'm here with my co-authors